Hello, Algebra 1 students. This is the very first video. This is on exploding dots. So this is probably a new concept. You may have heard of all of the ideas before, such as adding, subtracting, multiplying, dividing, um, but we're going to look at them in a different way, and hopefully there'll be something interesting for you. So let's start. By the end of this video, you should be able to check off that box. So here's a story. I am going to read it to you. So when I was a young boy, I invented a machine that was nothing more than a series of boxes that could hold dots. And these dots would, upon certain actions, explode. And with this machine and this non-true story, I realized I could explain true things. In one fell swoop, I explained all the mathematics of arithmetic I learned in grade school, all of the polynomial algebra I was to learn in high school, elements of calculus and number theory. So I'm going to begin to show you a lot of these things that are in the video. So we have a machine, and you see this right here? That means it is a 2-to-1 machine. That's how you read it. So what codes come from putting the following numbers into the 2-to-1 machine? So what I'm going to do is I'm going to put one dot in my machine from right to left. So I put a dot in the machine, nothing happens because we need two dots for something to happen. So our code, since I just have that one dot, is 1. Then let's say I put two dots into the machine. So in this case, I put in 1, 2. Well, those two dots exploded because it's 2 for 1. So those two exploded and one dot was moved on over to the other box. So that's what this is symbol saying. For every 2, you get an explosion and one moves over. So in our 2-to-1 machine, we can see that there's one dot in this box and 0 dots in that box. So that's where we get our code 1, 0. So I could go back, and this time I input a third dot. Well, I already have 2 in there, so let me put a third. So here's my third dot, and now my code is 1, 1, right? So those original 2 dots exploded, 1 moved over, I added a third dot, and now my code is 1, 1. Okay, for the sake of clarity, I'm going to start over, and I'm going to put all the dots in for you. I'm going to put 4 dots. Remember, when you get 2, they explode, and 1 goes to the other side. When you get 2, they explode, and 1 goes to the other side. Well, guess what? Again, we have 2, so we have another explosion, and now we have 1 over here. So in grand total, we have 1, 0 in this box, 0 in this box. So our code for 4 dots is 1, 0, 0. Okay, if we put in 5, that would be like adding just one more new dot from in our original. So there's 1. So our code for 5 is 1, 0, 1. For 6, we would add a 6 dot. We'd have an explosion. We move that one over. So now we have 1, 1, 0. See what's kind of happening right now? So in 7, we add another 7th dot. So we have 1 dot, 1 dot, 1 dot. Now I'm getting real excited. If I add 10, that means I need to add 3 more. So let's add 1, 2, 3. There's an explosion I can move over. There's another explosion I can move over. So now in this box, I have an explosion, and I can move a dot over. But there's one more left over. So I have 2 dots. Another explosion, move over. So in this code, I have 1 dot. This one is 0. This one has 1 left over still. And this over here has 0. So our code is 1, 0, 1, 0. And if we put in 12, that means 2 more. So what happens if I put 2 more in this box? Well, easy enough. We know that we get dot dot explosion. This dot moves over, which explodes this remaining dot, which sends another one over. And so we have 1, 1, 0, 0. 15 would be 5 more. I'm already talking for too long, so let's move on. So how many dots does it take to get to each box? So remember, one dot got us to the first box. So that's kind of like our ones. After we had two, we had our first explosion, and that took us over to that box. So that took 2 dots to get over there. If we put in another one, well, we don't get an explosion for that. We put in a 4th dot, then we get an explosion, and we get a second explosion. So it took 4 dots into our machine to get all the way into our 3rd box. Well, if we think about it again, if we do 4 more, that's going to take us into our next box. So if I put in 1, 2, 3, 4, explosion, 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 well, we put in 8. So you see what's going to go next? Then it'll take 16, and then it's going to take 32. You see the pattern? It's doubling. So how many dots does it take to get to each box? Well, we just showed you. Then we can go backwards, and it gets a little tricky. How many dots would you need to input to get the following code? 1, 0, 1, 0, 1. Well, let's explore that real quick. So using what we know about how many dots to go in, we have 1 dot in here, 0 dots in here, 1 dot in here, 0 dots in here, 1 dot in here, we can just add it up. 16 plus 4 plus 1 equals 21 dots. So there's a nice little nifty way of doing that. So let's move on to a 3-to-1 machine. So we can kind of explore this, put those number of dots in. So we put in 1 dot, nothing happens. We put in 2 dots, nothing happens this time because we need 3. So we had 1, 2. If we put in 3 dots, we get our first explosion and we move over. So our new code for 3 is 1, 0. If we put in a 4th dot, no issues there. Our code is 1, 1. If we put in a 5th dot, no issues there because we have, so we have 1, 2. And we put in a 6th dot, there we go, we have an explosion, and we have our second one over there. So 2, 0 is our code for 6. 7, no issue. 8, no issue. Not going to worry about those. 12 is when it gets kind of interesting. So let's see. Let's use what we did in the last time because that made things kind of easy. So if we put in, it's our ones, how many dots do we need to get to our next box? Well, remember 1, 2, 3 causes our explosion to move over. So that's our like 3s. 1, 2, 3 gives us an explosion that's over, not anymore. So that was 6. 1, 2, 3 explosion move over. That's 9 total that gets us into this box. So you can see we're not doubling this time, we're tripling. So then we'd have 27, 81, and that's enough. So for 12 dots, we know we're going to be in this 9 box. So we'll have a 9 plus 3 more is 12. So our code for 12 is going to be 1, 1, 0. For 15, well, let's think. We need a 9. Can we add another 9? Well, that would be 18, so that'd be too much. No. So let's add a 3. That's 12. Let's add another 3. So 9 plus 6, 15. So 1, 2, 0. 16, we just add one more dot. 1, 2, 1 would be our code. And 20, that's where we could do 9 and 9, 18. If we added 3, that would be too much, so we don't want any of those. 2 more. 18, 19, 20. So 2, 0, 2. So is it possible for a number to have a 2, 0, 3, 1 in a 1 to 3 machine? Well, think about that. If we had, let's say, 1 dot here, 3 dots here, 0 and 2. Is that possible? Well, no, because once we hit 3, we have an explosion and it moves over. So, no. And make sure you do a nice explanation. And what number has a code of 1, 0, 2, 2 and a 3-to-1? Well, we can solve it the same way. So we can do 1, 0, 2, 2. Well, we got 27 plus 3 and 3, so that's 6. Plus 2 more, so 27 plus 6 is 33, 34, 35. There we go. Moving on. So now we have a 10-to-1 machine. So 10 to 1 is actually not that difficult. So let's see, if we put in 3 dots, 1, 2, 3, well, that code is just 3. If you put in 9 dots, still not 10, so our code is 9. Once we hit 10, we get our first explosion. We have 1 dot move over, we have 0 dots left over, so our code is 10. If we add 5 more dots, 4, 5, 15. So nothing's really happening. I think that's pretty interesting. So, like, think about it. If we put 66, well, let's think about like what the code's like, what's happening. So we need 10. Those are our ones. We need 10 to get to the next box. And think about it. We're multiplying by 10 this time. So this is our hundreds. This is our 1000s. This is our 10,000s. And that's our 100,000s. It's just our base 10 number system. Why is this machine important? Well, this is how we use our numbers. Before, we were in base 3, and then now we are also in base 2. So implications in history, they used to use base 6, they'd use base 12, they'd use base 60. You'll have to look through and see a lot of them because the Babylonians and some other people, the Mayans, and all sorts of people in history use different base. We use base 10 because we have 10 fingers and toes. Well, that's at least the belief. We're not too sure, but that's our best idea. And so that's kind of cool.